Welcome back, friends. So we are getting into another session of ratio, proportion, and variation. So we have done a topic on fundamentals of ratio, proportion, variation, and the previous session was on problem level one, where we solve few problems and try to understand the basics through those problems in the previous session. So this session is primarily focused on the level 2 or a little advanced level problems in ratio proportion variation. The type of problem you typically expect in exams like CAT, ZAT, and to some time in exams like in MAT, SNAP, IFT, and also in some other competitive exams if the exams are trying to be a little more try to get their level a little high. That time you may expect some of this problem. So we'll solve around 6 to 7 problems of this type, and then we wrap up ratio, proportion, variation, and move to the next topic. So like we do every time, starts with the fundamental session that we did earlier, then a problem level 1 session to understand, to cement the fundamentals what we learned, and then go to the advanced level problems in the last session of a topic. So this is the last session of ratio, proportion, variation. So we will cover the advanced level problems here, and then we can move on. So let's start with this problem, and every time, if any problem, what after I explain, you are not getting or you need re-explanation, feel free to drop me a mail in the mail ID given in the description box. Otherwise, and the ideal way to use this video is try to pause the video when you see a problem, try to solve it by yourself, and once you solve it, or even if you know are not able to solve it, then again restart the video and see the solution. uh, so you can listen to the solutions right away, but I would suggest you, if you have understood the fundamentals and do the first level problems with me in the previous session, then you should see the problems, try to solve it by yourself, and if it is and once you solve it or unable to solve it, not a problem. In that case also, you can come back and restart the video and see it again. So that way you will use this session most effectively. But with that, let's get started. So the first session problem, see there are so a similar problem we did in the level 1 session of ratio, proportion, variation, where there were two incomes given and two expense given, and they're asking for the savings rate. So this will be a little extrapolation of that particular concept. So if you see, the problem talks about there are 3% A, B, C whose income ratios are given and the expense ratios are given. And they said each of them saves some amount. But what is that amount that is not given? What is the percentage of that amount that is also not given? So they said they just save some amount, and whose saving as a fraction of his or her income will be the highest. So if we start, we know that savings is basically your income minus expense, right? They said whose savings as a fraction of his income. So they can't say savings in terms of absolute value, because they said some savings. So the sum does not qualify to make it a absolute value, so that we can compare each of their saving numbers. But what we can do is savings as a fraction of income. So if we say savings as a fraction of income, so this ratio has to be the highest for whom that's what they are asking for. So savings, we don't know in terms of absolute value. So savings, we can easily say that savings is basically what is left after expense, right? So can I say savings? So basically, you can write savings is nothing but income minus expense by income. In that way, you can write 1 minus expense minus by income. So savings as a percentage of interest will be higher for that person who has this ratio as lowest, because this is getting subtracted from 1. So expense by income has to be the lowest for that for a person to become the savings by as a percentage of income will be highest, because if your saving has to be as a percentage of income has to be higher, your expense as a percentage or as a fraction of income has to be lower. So with that concept, we can say expense by income, this fraction has to be lowest, for whom the person, for that person only, the savings by income has to be the highest. So if we go ahead with this, so income wise, I know income of A is to income of B is to income of C is typically 4 is to 8 is to 9. So this can be, we can say 4x, 8x, and 9x. So for savings as a percentage of income for A will be savings. So we'll see expense as a percentage of income. If I say A, for A, it will be 6y by 4x, because the ratio is of expense is 6 is to 11 is to 15. So again, don't consider the same variable for both income and expense, because the total is different. So there is no relation between the 4 there and 6 there. So if you consider 4x there and 6x there, you are somewhere assuming there is a relation between the 4 given in income of A and 6 given income of given in the value of expense of A. So there is no relation between that 4 and 6. So don't consider the same variable like 4x and 6x. So it has to be a different variable for a different entity. So income is a different entity, expense is a different entity. And that's why we said 6y by 4x. Similarly, expense by income for B will be typically 11y by 8x. Expense by income for C has to be 15y by 9x. So again, just took everyone's expense value that is given and divided by the income value that is given. So if you see this, y by x is common in all the cases. So basically, we have to focus on whether 6 by 4 is more, 11 by 8 is more, or 15 by 9 is more. So if you just make it possibly a fraction, so this is 1.5 times y by x. This is typically 1.3 times y by x. And this is typically 1.6 times y by x. So obviously we can see for B it's the lowest. So for B, expense by income is lowest. That means for B, savings by income has to be the highest. So your answer is B. Person B has the highest fraction of savings by interest. I hope it's clear. So what we did, we tried to understand the relation between savings and income and expense. So from there, we find out savings by income will be highest when expense by income will be lowest. Then from there, we tried to form the expense by income fraction for each of the 3% A, B, and C, and then C for whom expense by income is the lowest. And we find out expense by income is lowest for B. So our answer should be B, because expense by income is lowest for B. Savings by income will be highest for B. Oops, clear. Let's move to the next one. So, just give me a minute. So the next problem we're going to talk about. So they said there are 2,000 soldiers for which the provision is available for 35 weeks at the rate of 1.6 kg per day. Okay. If some more soldiers join the battalion, the same provision would last only 20 weeks at the rate of 2 kgs per day. Find the number of soldiers joining the battalion. So in this problem, I think you typically need a ratio, though you can solve it with a ratio, but there are simpler approach. Let's try to do it with that, because our goal is to solve a problem, not particular, solve a problem in a particular way always. So if there are 2,000 soldiers, if there are 2,000 soldiers, they have supply lasted for 35 weeks, and and the rate of 1.6 kg per day per person. So 1.6 kg per day per person. So per day per person. So total is what? Your soldier into number of weeks, or I will say number of days into supply per day per person. So there are, for in first instance, there are 2000 soldier. This is basically nothing but your total supply. So this equation is nothing but your total supply. So soldier into number of days into supply per day per person is basically nothing but your total supply. So in the first instance, there are 2000 soldiers. They have number of days means 35 into 7 days. 35 weeks means 35 into 7. And per day per person is needed 1.6. So this is the total supply they have. Now in the second case, so this should have been the total. Now in the second case, they said there are few new soldiers joined 20 weeks at the rate of 2 kg per person. So let's say the after joining new soldiers, so there are now currently there are X soldiers. So 2000 X is obviously more than 2000, but let's say there are X soldiers after few new soldiers has joined. So what I need to find out is what is the value of X minus 2000. That will tell me how many new soldiers have joined. So X, it lasted for 20 weeks, 20 into 7 into 2. So this is also the total supply, 2 kgs per day per person. So if I just then equate this to equation, 2035 into 7 into 1.6 x into 20 into 7 into 2. So 7 get cancelled out. 2000 becomes 1000. So we can say x is equal to 35. So 35 into 1.6, how much it's become? 56. Yeah, 56 into 1000 divided by 20. If I do with this, 20 means it will be 50, so 56 into 50. 2800. So X is 2800. So basically there are 800 new soldiers was joined. So we got X equal to 2800. So basically what we understood is the total supply is basically the number of soldiers and number of days and how much supply is needed per soldier per day. So that's basically multiplication of all these three quantity gives you the total supply. So once you get the total supply, in the first instance, you know all the variables. In the second instance, you don't know the number of soldiers. So we have assumed that the number of soldiers in the second instance is X. So then we equate this to equation and then get the solution of X. It's equal to 2800 we got, and then that means the number of soldiers who has joined new is 2800 minus 2000, which is 800 new soldiers. So 2000 was there earlier. Now there are new 800 soldiers has joined. So the next problem. They said the again, pause the problem, try to solve it by yourself, see what you can get, where you are stuck, and then come back and see the solution. They said the reduction in the speed of an engine is directly proportional to the square of the number of bogies attached to it. So can I say reduction in the speed, not the actual speed? So speed. So this is not the speed directly. Don't try to write the equation where you said speed is directly attached to speed is proportional to the number of bogies, because it's the reduction, speed reduction is proportional to square of the number of bogies attached to it. So they said the speed of the train is 100 kilometer per hour when there are 4 bogies, 55 kilometer per hour when there are 5 bogies attached to it. What is the maximum number of bogies that can be attached to the train so that it can move? So basically, when I say the train can move, so basically I need to see at which level, uh, your number of bogies will be so much that your speed becomes zero. So if your speed becomes zero, then after that, we possibly need to know that's the maximum number of bogies it can carry, or possibly a bogie number which is one less than that is basically the train can carry. So that's where we need to solve the problem with. So if you see, we're talking about the speed reduction. So to understand speed reduction, what they have given is they have given the speed of the engine is 100 kilometer when there are 4 bogies. So that means there are some speed reduction has happened because there are 4 bogies attached to it. So let's say 0 bogies, the speed is x kilometer per hour, let's say. So with 0 bogies, the speed is x kilometer per hour. So when you say speed is 100 kilometer, that means speed reduction has happened by x minus 100. This is the speed reduction. X is basically the speed without any bogie. So x minus 100 is the speed. X minus 100 is the speed reduction that has happened when there are, let's say, 4 bogies. So that is as 4 square. So from here we can write x minus 100. Again, the concept of variation, constant of variation will come into picture, k into 16, right? Similarly, in the second case, we can write there are speed is 55. So speed is reduced to 58. So x minus 55. That much speed reduction has happened because 55 is the speed. So that means speed has reduced from x to 55. So x minus 55, the k into 5 square, or we can say k into 25 because there are 5 bogies attached to it. So we got two equation, two variable x and k. Let's try to figure out both of them. So from here, we can, if we can write x minus 100, let's say minus x minus 55 is 16k minus 25k. So then it will become minus 45 is equal to minus 9k. From there, we can say k is equal to 5. So we know k is equal to 5. And if we put back the value of k in any one of the equation, we will get x minus 100 is equal to 5 into 16, or x is equal to 100 plus 80, or 180 kilometer per hour. So 180 kilometer per hour is the speed when there are no bogies attached to it. So basically, what is the maximum number of bogies they can attach when the speed is reduced by reduced to zero almost? That's the maximum number of bogies. Possibly one less than that is what we try to capture. So let's see, by attaching how many bogies your speed will become zero. So in order to speed becoming zero, your speed reduction has to be 180 itself. 180 is the speed without any bogie, and to speed becomes zero, you have to reduce the speed by 180. So yes, again from this equation, this same thing we can write 180 must be equal to k into n square, where n is the number of bogies attached to it. So k we know 5, so n square must be 180 divided by 5, or 36. So from here we can say n is equal to 6. So we can say if you attach 6 bogies to it, the speed will become zero. So you cannot attach 6 bogies to it. So your answer should be maximum you can attach 5 bogies so that the train can move. So again, understand this part very well. When we say we will attach 6 bogies to the train, the speed of the train will become 0. The question is, what is the maximum number of bogies that can be attached to the train so that it can move? So if the speed becomes 0, the train will not be able to move. So you have to reduce 1 bogie so that the train can move and it is not stuck at speed of 0 kilometer per hour. So with attaching 6 bogies, the speed becoming 0. So we can maximum attach 5 bogies so that the train has the capacity to move. So the answer is 5, not 6. So be very critical on this, understand this very well, and then go ahead and solve the problems. Always understand what is being asked, then go ahead and solve. Okay, let's move to the next problem. The next problem typically talks about Arvind Singh. Arvind Singh purchased a 40-seater bus. He started its service on route number something 2, which the distance is 50. His profit on the bus depends on the number of passengers. So number of passengers more means profit is more. So I can write profit is directly proportional to number of passengers. Let's say that is n. And they say number of minimum passengers. So let's say the number of minimum passenger n. So basically he needs at least n passengers to get the profit. We will write that equation. So basically he needs minimum n passengers. So with n passenger he may not get profit. So let's say there are x passenger. So let's do this. So let's say there are x passengers. Just writing. Let's say there are x passengers, and x is obviously more than n. N is basically the minimum passenger required to get a profit. So more the value of x minus n, more the profit. So profit is proportional to x minus n. So x is the number of passenger, and if the value of x is more than n, then you get profit, and more the value of x, so that the value of x minus n is more, your profit will be more. So that's what we are writing here. And so then they said, and it's also depends on the distance traveled by the bus. So profit is also dependent on the distance traveled by the bus. Let's say the distance travel is y. So from the joint variation property, with using these two, we can write P varies as x minus n into y, or we can say P is equal to k into x minus n into y, right? K is the constant of variation. So this is the concept that we are going to use. So what they said in the first case, the profit is 3,600. So 3,600 is the profit. 3,600 is the profit. They said with 29 passengers. And when they say with 29 passengers, you are getting a profit, means 29 is surely more than n. N is basically the minimum passenger required to see a profit, because there are always a cost involved. So you need some minimum number of passengers to cover the cost, and then more passengers on top of that will give you more value than your cost, and that's when you get profit. So I say, so k 29 is the x, so 29 minus n into 36 kilometer. 36. What is the second equation talks about? The second equation talks about, let's say this is my equation 1. So this is my equation 1. The second equation talks about 6,300 is the profit when there are 36 passengers and 42 kilometers. So 6,300 is the profit into 36 passengers and typically 42 kilometers. Let's say this is equation number 2. So we've got two equation. Again, there are two variables. Sorry, 36 minus n. It has to be 36. 36 minus n into 42. So this is equation 2. So there are two equation, two variable. A and n is unknown. So let's go ahead and let's try to solve this. Let's say we do 1 divided by 2. So from here we get 36 by 63 on the left hand side. K will get cancelled out. 29 minus n divided by 36 minus n into 36 by 42 if you divide 36 by 42, right? So 36 will get cancelled out. 21 if you do this 2, this 3. So if you just do 2 into 36 minus n will be equal to 3 into 29 minus n, right? So from here we can say 72 minus 2n is equal to 87 minus 3n, 3n on the one side. So n will become 87 minus 72, 15. So 15 passenger is the minimum passenger. So what is the minimum passenger required that he will not suffer any loss? So he will require 15 passenger to not suffer any loss. 16 passenger onwards, he will start earning profit. So again, what we did, main part of the problem is to try to get the profit right. So once you get the profit, the equation of the profit, right? So profit is basically your number of passengers minus minimum number of passengers that is required to get the profit into the distance that they have traveled. So they have not said, so this is a problem where they have not said typically varies as directly or something, but this is something for you to understand and write the understanding of the variation. So obviously more the number of passenger above the minimum level is more the profit. So it has to varies directly. And the second case is more the distance you cover. Typically, the charges are a little high. If you cover more distance, so then more the distance is covered, more the profit. So it's your understanding of the context to make the equation. So every time they will not specifically tell you is varies directly or varies in which way, direct, inverse, something, but they will just say it depends on this and this. So your understanding will tell you it depends on, so the number of passenger more, profit more, so direct proportion. Distance more, profit more, so direct proportion. So then apply joint variation to get this equation right. Once you get the equation right, then you just have to put the values in the equation and solve it. Move on to the next problem. So they said this is a very good problem and came multiple times in exams like that. So they said a precious stone fall down and broke into three pieces, 3, 4, 5. The value of the stone is proportional to the square of its weight. So the value is proportional to the square of its weight. So we can say the value is k into W square. And if the original value of the stone is 57,600. So again, the stone, let's say there was a big stone. It has broken into three pieces. And 3x, 4x, 5x is the weight. So 3x, 4x, and 5x. So these are the small pieces. It has broken into three small pieces, and each piece is 3x, 4x, 5x. So can I say W1 is equal to 3x, part of the second 4x, and W3 is typically 5x. So what is the total weight? Total weight. So this is the W equal to 12x. So the total weight, if things are broken and their individual weights are taken, that's the sum of their individual weights is equal to the total weight of the stone. So the total weight of the stone is 12x, and it's broken into three pieces, 3x, 4x, 5x. But even if you add all the individual pieces and get the total weight, their values will differ because values are not directly proportional to the weight, it's proportional to the weight square. So what they have said, 57,600 is the value of the original stone. What is the loss due to the breakage? So 57,600 is the value of the original stone. So K, original stone's weight is 12x. That means 12x whole square. So can I say Kx square is 57,600 divided by 144, right? And if you actually calculate, it will become 400. So Kx square is 400. That's what we got, right? Now, individual stones ka value we need to find out. So individual stones, so value of the first space, let's say V1 is K into 3x whole square, because that's the weight of the first piece. So that is basically Kx square into 9. Similarly, value of V2, can I say Kx square into 16, because this is 4x, so 4x whole square, K into 4x whole square. And value of the third stone, Kx square into 25. So if I add all these individual values, V1 plus V2 plus V3, it becomes Kx square. 9 plus 16 plus 25. So 9 plus 16 plus 25 is for 50. So 50 into Kx square. Now Kx square I know is 400. So 50 into 400. So that will become 200. So that is becoming 20,000. So that is becoming 20,000. So now the individual values together is only 20,000, right? And the actual value was 57,600. So what is the loss? So the loss is 57,600 minus 20,000, or 37,600 is the loss. This is the loss. So how we calculate the loss? We understood what is the individual weights. From there we calculate what can be the total weight, which is the sum of the individual weights. So the total weight is 12x. If individual weights are 3x, 4x, 5x, so the total weight is 12x. So if the total weight is 12x and the original value is 57,600, then from there we know the value of this constant, and from there we can use that understanding of the value of the constant, which is 400. We can calculate the value of each of the individual stones. So K into 3x square, K into 4x square, K into 5x square. So Kx square we know. So with summing up all of that, we know the value of sum of all the values of 3 individual pieces is not more than 20,000. So the difference happens because weight is not directly proportional to the value. Value is proportional to the square of weights. So 12 square, the value is different from the sum of values of 3 square plus 4 square plus 5 square. 12 may be individually equal to 12 equal to 3 plus 4 plus 5, but 12 square will have much higher value than 3 square plus 4 square plus 5 square. And that's where the loss is getting generated, because value is proportional to the squares, not the individual directly to the weights. Hope it's clear. If not, you can drop me a note, but this is a very important problem and came to multiple times. So sometimes they may tell you this is the number of loss, find out the actual value. Sometimes they tell you the actual value of the stone and ask you to find out the loss. So either way, but the approach remains same. Last problem for the day. So they said the salary of a executive consists of two parts, a fixed part and the variable part. So when I say salary is fixed plus variable, which is dependent on the number of items sold. So variable part, so there's a variable is proportional to the number of items sold. So let's say the person sold X items. So it can become V equal to Kx, where K again is the constant Kx. So can I say salary is then fixed plus plus kx, where x is the number of items sold. Now this they have given you two scenario. 120 articles, he get 45,000. 180, he gets 60,000. Okay. So in the first scenario, he gets 45,000, where there is a fixed component, and then there is k into 120. So let's say this is equation 1. Next scenario, he gets 60,000 f plus into 180. So this is equation 2. So again, equation 2 variable f and k. Let's try to figure out that, and then we will go to what has been asked. So but also even know what is asked. The ask is salary of the person if he sells 150 articles. So basically you need to find out the salary when he sells 150 articles. So for that you need to know f plus 150k. So you need to know the value of k, you need to know the value of f. So both the values you need to know. So use 1 and 2 equation to get the value of f and k. You can do it by yourself, pause the video, do it by yourself, and then come back and see whether you have done it right, or if you are stuck, you can see. So moving on, so how we can do it? Typically, let's do 2 minus 1, and then we get 60 minus 45,000, so 15,000 on the left hand side. F plus 180k minus f minus 120k, so f gets cancelled out, so 15,000 is equal to 60k, or I can say k is equal to it is equal to 250. If I am done it right, 250. You see, yeah, k is 250. Okay, so we got k as 250. Now, if we know k as 250, can I find out f? So let's put it in the first equation. 45,000 is equal to f plus 250 into 120. So that gives me 45,000 is equal to f plus 660, 30,000. So f is nothing but 15,000. So you know the value of k, you put it, and you get the value of f as 15,000. Now coming back to this particular piece, so what will be the salary? So I know this is 15,000 plus 150 into 250. So 150 into 250 plus 15,000. So if you do that, and just do the calculation here so that you can understand. 15,000 plus 150 into 250. So this gives me 15,000. 150 into 250. If you do 150 into 0 is 0. 150 into 5 is 750. 75, 300 plus 75, 375. So 37,500 plus 15,000. So 52,500. So 52,500 is your answer. And so you can understand, by selling 120 article, he gets 45, 180 articles, he gets 60. So by selling 150, it should be between 45 and 60. So 52,500 is your answer. So these are the different type of problem that can come from ratio coefficient variation if it has to be a little complex. We have solved different type of problem where the problems are not given explicitly, where the problems are given explicitly, but you need to understand the relation between the multiple things that are given, typically the weight and the value problem, or all the bus wala problem where there is not explicitly said the number of passengers, number of the distance covered, and the profitability, the relation. We also understand from how income savings can be related to the ratio that we calculated in the first problem. So we have to solve various kind of problem. If you need further help, or if you are stuck in some of the problem, feel free to drop me a mail and we can take it from there. So hopefully the session is helpful. You got a decent understanding of ratio coefficient variation through all the three sessions. Now you can try more problems at home, and if you need any help, again, drop me a mail and we will take it from there. So hopefully this is helpful. Uh, Thank you. Or before closing, if you are finding it difficult that the mail is taking a little more time to respond, you can also put the problems in the comment section. We will try to solve it there. But let me know wherever you have doubt. If you are finding that dropping a mail is difficult, you can also, I would suggest, first drop a comment in the video, and then from there that is easy for me to come and quickly solve it rather than responding in a mail. If it is required, I will possibly ask you for your mail ID, and from there I can reach out to you. Whatever is convenient to you, you can drop me a mail or you can drop a note in the comment. Both are fine. Okay, so hope the session is helpful. Hmm. Thank you.